Hi everyone, so this is still section 5.5. In the last lesson we learned, or just reviewed really, adding, subtracting, and dividing functions those are operations, right? Adding, subtracting, dividing. The last operation is very new to us, and what this operation is called is it's a composite function. Okay, so a composite function is the result of applying the rule for one function to the rule of another function. Okay, sounds a little tricky just to start, but let's take a look at some examples. The notation, I don't know if I can zoom in here really quickly, but it's this little circle. So it's f, and how we would say this is f composed of g. It's this open circle, okay? And it looks silly like that, but let's take a look here. So like I says, it's this little open circle, tiny little open circle, and this says f composed of g of x equals, this we can read, f of g of x. Function notation, notice there's two functions, g of x, which is inside of f of x, two functions right there. The operation that forms a composite functions is called composition of functions, okay? And that's what we're going to practice and work with today. So like I said, here's the notation, f composed of g of x. As soon as we see this, I want to rewrite it like this, f of g of x. Put the g of x in for the x in f. It doesn't just have to be the f first, it could also be g composed of f of x, which equals g of f of x. We always start with the inside function. We put the inside function into the outside function, okay? And we're going to take a look at what that looks like. So we always have to be given two functions. So here they give us f of x equals x squared and g of x equals x plus 1. So what do we do? Okay, it says find the rule for f of g of x. Remember that could also be written as f composed of g, we should put parentheses around this, of x. Worst parentheses I've made in my life. Okay, and so what we do is I'm going to here write down the outside function. My outside function is f. So if I write down f of x equals x squared, my next step is to write the composition. So this is a function made of x's, right? F of x equals x squared. I now want to make this f function a function of g of x. So wherever I have an x, I want to put the g function. Okay, so my g function is x plus 1. I want to put that in for x. So in for the x, I put x plus 1, still gets squared. So it's not x squared, it's x plus 1 gets squared. Notice the x isn't there anymore. It replaces, okay? Think about just like if it was like f of 2, right? You would put that 2 in for the x, and the x would be gone. From there, we just simplify. X plus 1 squared, I want to rewrite as x plus 1 times x plus 1, which then we know to FOIL, and that's it. Okay, and that's all this is. The tricky part, I guess, is right here, figuring out what goes where. Let's take a look at another one. So, well, if I do, here's f of x and here's g of x. I first want to figure out what f of g of x is. Okay, and what we're going to do, I'm going to zoom in actually. What we're going to do is scroll out here, sorry. I don't want you guys to see what's over here. Okay, here we go. Little fix of my slideshow really fast. Don't look what's under there. Perfect. Okay. Okay, but we can see that function. So we're going to do f composed of g of x. As soon as we see that composition of functions, I want to rewrite it with function notation. Just kind of gets written in order, right? These two are the same thing. These are equal. Okay, now I know I'm going to start with that f of x function. So f of x equals 3x plus 1. But now I want to write this in a function where now I will have g of x in for my x. So I'm not going to write 3x plus 1. I'm going to write 3 times my g of x, x minus 2, plus 1. See how it completely just erased the x, replaced and erased. And then we just simplify it. So I'll distribute the 3x minus 6 plus 1, and then combine like terms. -6 plus 1 gives me -5. And that's all. Over here we can do the same thing, but notice here this is the first time we're looking at g composed of f of x, which we will write as g of f of x. I start with my g function, which is x minus 2, and then I put the f of x in for the x. So it's going to be 3x plus 1 minus 2. This whole thing gets replaced. And then we just simplify. So I'll have 3x plus 1 minus 2. Those parentheses don't mean anything in this case. Combine like terms, and I will have my 1 minus 2 gives me -1. So there's another thing that could possibly happen. So this says f of g of x, and this would be my answer. So if that was the question, here is my answer. F of g of x equals 3x minus 2. What if it said f of g of 2? So what do I do with this 2 here? Just like in regular function notation, we go through and I put the 2 in for my x. And then we will simplify. 3 times 2 gives me 6. 6 minus 5 is 1. So then I actually end up with an exact numerical answer, just like that. Okay, here's another example over here. Maybe I wanted to do g of f of 5. I want to put that 5 in for my x and simplify. So I will have 3 times 5, which is 15. 15 minus 1 gives me 14, and I have an exact answer. So if you have an x, you will have an expression, an equation here at your final answer. If you have numbers for that x, you'll have a numerical answer. Okay, this is called composition of functions. You're going to practice it. Awesome job, guys.